Well, hello Internet, and welcome to part 6 of my Precalculus tutorial series. I have been receiving a ton of questions about exponents. So I decided that in this video, what I'm going to do is I'm going to go over about the top 30 exponent rules and things you need to understand to solve just about any exponent problem you could ever see. And I set this up so that you'll be able to see the problem, pause the video, solve it on your own, unpause it, check your results, and do this over and over and over again 30 times. And if you do that, I think you'll master working with exponents. And I have a lot to do, so let's get into it. Okay, so I'm just going to go through these exponent rules one after another. So first, if you come across a situation in which you have a base which is represented with a, and then you have exponents that are two different values, you are going to end up adding those values together to get your result. And let me give you an example, and you can pause your video after you see this, just so you can go and work through it yourself and see if you got it right. So we're just going to add 2 plus 3, and that is going, whoops, I made an error. Let's go get rid of that and put a 2 inside of there. There we are. And that's going to give us 2 to the 5th power, which is going to end up being equal to 32. All right? Now, on the other hand, let's say you have the same exponent, but you have two different bases. How's that going to work out? Well, you're just going to multiply those base values together and then get the exponent of those. And I can show you another example. Well, let's just keep this 2 and then 3, 2. Of course, the exponents are the same. To get your result, you're going to take the 2 times the 3, and you're going to get a value of 36. Let's continue. And let's say you have a different exponent, but the same base, and they are divided this time. So you have this. That is going to work out to being a(n) minus m. And let me show you an example. So let's say we have 2 to the 4th divided by 2 squared. That's going to end up being equal to 4. All right. Again, this time we're going to have different bases, and we are going to have the same exponent. In that situation, you're going to go a divided by b and whatever the exponent is. And another example here for you. So, like this, this is 2 to the 3rd, let's try, is going to be equal to 4 over 2. And this is going to be 2 to the 3rd, which is going to be equal to 8. All right, let's continue. Now let's say we have a base value and an exponent and then another exponent. How do we solve this? Well, a(n) times m, and I can give you an example. So 2 to the 3rd and then squared is going to end up being equal to 2 to the 6th, or 64. Do another problem here, then I'll clear this screen so you can see a little bit better. This is going to end up being equal to a, and then you're going to have whatever n to the m is. So let's say we have 2 to the 3rd, and then this is squared. This is going to end up being 2 to the 3rd squared, which is going to be 2. That's 3 times 3, which makes this a 9, which is going to give a value of 512. All right, so hopefully you're working your way through these, or at least you plan on doing it afterwards. Because let me tell you, people ask me all the time, Derek, how do you learn things? You know how I learn things? I repeat them over and over again. I use tools like Anki, A-N-K-I, and I do repetition learning. That is how I learn everything. And I'm setting this up so that basically you can do repetition learning. And if you do this a couple times, you'll master it. So this is going to be solved with 2 to the 6 over 3, which is going to end up being 2 squared, which is equal to 4. Again, another one. Let's say your exponent is a fraction. In this situation, you're going to convert it to this form, like that. And an example would be 27 1/3 is equal to And then you'll get the cube root of 27, which ends up being equal to 3. And another one, let's say you have a negative exponent. That's going to be equivalent to 1 over an. And an example, negative 3 is equal to, this is going to end up being 1/2 to the third, which is going to end up being equal to approximately 1.25. Throw in two other little rules here. If you ever have a 0 exponent, I don't care what the base is, that's always going to equal 1. And, if you want to see an example of that, there that is. And let's start talking about adding exponents here, specifically some really weird things. All right, so let's say we have a to the n plus b to the m. You can see right there, the bases and the exponents are different. Well, this is how you would solve that. Let's say 2 to the third is equal to, and you're just going to work those out. So that's 9, that's 8, and of course that equals 17. And let's say that we have the same bases and the same exponent. That's going to end up being 2a to the n. And an example of this would be 3 squared plus 3 squared, which is end up being 2. And then 3 squared, which is going to be 2 times 9, which is equal to 18. Again, let's say we have two different bases and two different exponents, and they're negative this time, and we want to add those. Well, there we are. And this is going to be 1 over a to the n plus 1 over b to the n, or m. Sorry about that. And this is going to work out to 2, negative 3, plus 3, negative 4, which is 1/2 to the third plus 1/3 to the fourth. And this ends up being equal to 1 over 2 times 2 times 2 plus 1 over 3. Well, I'm just going to leave it 3 to the fourth. I think you get what that is. This ends up being 1/8 plus 1 over 81, which is approximately equal to 0.137. Let's do another one. All right, let's say we have we're using a fraction here again. We're adding, the bases are different, and also the exponent fraction is different. And this is going to translate into m a to the n plus j b to the k. And let me see an example. So let's say you have 3 and 3 over 2 exponent 2, 5 over 2 exponent. This is going to work out to being squared, which comes from this guy right here. Okay, that's where the square root comes from. 3 over 3 plus, and again, I think you get this, 2 to the fifth. And of course, this ends up being equal to square root of 27 plus square root of 32. All right. Now I'm going to cover a whole bunch of different odd ways you can multiply exponents. So let's say you're multiplying negative exponents with the same base. So a negative n times a negative m. Well, that's going to be solved by going a negative and n plus m, like that, which is going to end up giving you 1 over a n plus m, however you'd like to look at it. And example, negative 3 exponent, same bases, again, like I said, is going to be equal to 2 negative, and this will be 3 plus 4, which is equivalent to 2 negative 7. And if you have any questions, of course, tell me. I want this to be an interactive tutorial in which I can answer all your questions. And if at any point in time I don't explain something to the point that you understand it, tell me, and I will try again. I definitely believe that if a student fails, it's the teacher's fault. So as long as the student shows up. Okay, so this time what I'm going to do is I'm going to cover multiplying when bases are different and the exponents are the same. Well, that's going to be solved with a times b negative n. And an example of how that would be solved is 4, -2. So these are just rules that we are memorizing. 3, 4, and -2. And I am a believer, at least for me, that repetition is a way to remember these. So maybe that doesn't work for you. Try something else. But why not try repetition? Okay, so there we go. Now what are we going to do whenever the bases and the exponents are different and we have negative exponents? Well, we're going to see an example of that here. So we'll have b and -m. That's going to end up being 1 over a to the n times 1 over b to the m. And an example of this would be 3 -2 times 4 -3, which is going to be equal to 1 over 9 times 1 over 64, which is going to be equal to 1 over 576. And I have no idea what that is equal to, but you can figure that one out. Okay, let's continue. Let's say we want to multiply fractions with exponents with the same base. So let's say we have a over b and same base. Remember I said a over b and different exponents. Well, that's going to end up being equal to whatever a over b is, n plus m. And let's go and see another example. So 4 over 3 times 4 over 3 squared is equal to 4 over 3. And we add the exponents, which is going to end up being equal to 4 over 3 and a 5 exponent. All right? And you can work that one out as well. Let's do some more here. Let's say you want to multiply fractions with the same exponent. So we'll have something like a over b and n times c over d n is equal to, and that's going to end up being a over b times c over d, like this. And then this whole thing is going to be taken to n. And an example of this would be 4 over 3 to the third times 3 to the fifth and to the third. And we can just go 4 over 3 and 3 fifth, and then multiply those and then to the third. All right? And that's going to end up being equal to 4 over 5 to the third. All right? Okay, let's try another one. Let's say we want to multiply fractional exponents with the same exponent. So that would work out to being a n to the m times different base n to the m, which is going to end up being a times b n to the m. Maybe you're seeing a pattern start to develop here. And so let's see an example. Times 3 over 2. This is going to end up being equal to 6. 2 times 3, 6. 3 over 2, which is going to be equal to the square of 6 over 3. Of course, the square comes from there. We've seen that in a previous rule. And let's do another one. Let's say we want to multiply fractional exponents with the same base. So, and of course, the fractional exponents are different. So this is this times a k over j. And to solve this, this will be a, and then this exponent part will be n divided by m plus k over j. And an example of this, let me try to write this a little bit bigger so it's easier to understand, or see, I mean, times 2, 4 over 3. This is going to be equivalent to 2, and then inside of here, this would be 3 plus 2 plus 4 over 3, like that. And that works out to being approximately 7.13. Okay, let's try another one. This one is multiplying fractional exponents with different exponents and bases. All right, so this, it'll be a n over m times b k over j. Well, this is going to be solved with That's the m part. You can see where that comes from, the denominator of the first one, and then there's the base, and there is our numerator, times, and let's try this again. This is going to be the j part, and this is going to be the bk. And an example solving this would be, let's try 3 over 2 times, and 4 over 3, which is equal to, and I can just do the square for the first, or square root of the first one, times, and then we will do the cube root, 3 to the 4th. And one more here before I get into some dividing. Let's say you have square roots with exponents. Well, in that situation, if you have a to the n times square root of a to the m, you're going to solve that by going a and then adding n plus m like that, and divide that by 2. All right? Okay, now dividing exponents. 6 more, and then you are a master of exponents. Let's say we have negative exponents with the same base. So that's going to be a negative n over a negative m. That is going to be solved by just simply taking a m minus n. Example, negative 2 to the negative third divided by 2 to the negative fifth is going to end up being 2, and take the 5 minus the 3, which is 2 squared. Let's say we have different bases, same exponent. So it would work out to being a like this, divided by b, negative n is equal to, we would solve this by taking the a divided by the b, and the n on the outside, the negative exponent, and we could also simplify this, then get the negative part of it and get the reciprocal of it, and there we go. Example of this, negative 2 divided by 4, negative 2, which would end up being 4 over 3 squared. All right, 4 more. Bases and exponents are different. So in this situation, we have a negative n divided by b negative m, and this would be solved by taking b m divided by 8n. Let's see an example. So we have 3 negative 2 divided by 4 and negative 3. This would end up being equal to 4 to the third divided by 3 squared. Now we're going to talk about fractions with the same base and different exponents. So let's say we have a divided by b, n, and this is divided. And again, we're going to have a divided by b and m. We will solve this by going and getting a divided by b and taking n minus m. Example, 4 thirds and the third divided by 4 thirds squared is equal to just the 4 and thirds and 3 minus 2, which of course equals 4 thirds. 2 more. Okay, let's say we have different fractions, same exponent. So this is going to be a over b to the n divided by c over d to the n. This will be solved by coming in and let's go a times d over b times c like this. And a real world example would be, let's say we have 4 over 3 to the third and divided by 3 over 5 to the third. That would be solved by taking the 4 times the 5 and dividing it by the 3 times the 3 and to the power of 3. And for the final one, different base and exponent. So this would be a divided by b and n divided by c over d to the power of m. And the way this is solved is to go for thirds, like this, to the third, and divide it by 1/2 squared. Just straightforward. All right? So there you go, guys. There are numerous different ways of solving about 30 different exponent problems that you are sure to come about. And like always, please leave your questions and comments down below. Otherwise, till next time.